new in version 14.2, video and image computation. In version 14.1, we introduced video summary plot, which is a static plot that shows basically a list of video frames with audio or without audio, whichever one is preferred. Version 14.2 is introducing highlight video, which is obviously a dynamic over time summary of what has happened. And we'll talk about some functionality that has been added, but as a simple thing, if you say highlight video, a given video, and a function like find faces, that function is evaluated on every frame of the video and then applies the result, which comes back as regions, as points, polygons, binary images, whatever it could be, the result of that could be highlighted on the video, just like we had highlight image before, gets displayed on the image. Here I have a different example of highlighting detected bounding boxes or objects on a video. Here, image bounding boxes is giving association of labeled bounding boxes, unlike find faces. So these are being labeled with the automatically chosen color for each object. Similarly, that could be done for points, like image corners, could be done for a fixed graphics primitive or a graphics object like that, or could be done by a graphics that gets, or could be done for a given, actually this one could be also a function that gets, generates a graphics over time. And this last example I had was showing that the highlighting can happen for just a given time. So these are some utilities that I'm going to be using a lot in the rest of the presentation as I talk about VideoAnalysis 14.2. So introduced in earlier versions, I think as early as 12.3, we had a family of functions that we refer to as video map family of functions. For instance, video map time series, that if I look, let's quickly take a look at, takes a video and then applies a function, returns for each time a value. And then as an example of that, let's quickly look at the result. For instance, here I have a video. I specify a function that's an image measurement of the frames of the video. I compute the mean value of each channel coming back as a vector of 3 numbers. And then I'm plotting that as an RGB plot. So this is basically how much the R, G, and B, red, green, and blue values of each frame is changing over time. So that was a family of generic functions introduced earlier. Version 14.1 updated a whole family of audio functions, such as spectrogram, speech recognize, and then some audio processing functions, such as audio amplify, and so forth. And then as a result, if you just pass a video function to some of these, a video object to some of these audio functions, you get the result back as you would get it from an audio track or an audio object. Now, in version 14.2, we are continuing on that effort and updating image functions that would make sense to operate on a video and return an analysis. Now, these functions have been updated to return the result of the function applied to every frame of the video as a time series. So for instance, here I have a face detection operation happening on a video. So just like I had find faces of an image, I can do find faces of a video, and then I get a time series back. Let me evaluate that because, oh no, I didn't need to evaluate that. So just like time series can be inspected at a given time, here I'm doing faces at 0.5 at time 0.5, and I get a list of rectangles that are corresponding to the detected faces at that time in the video. And then as I showed highlight video, I can pass that time series of faces, the one that came back up there, to highlight video in addition to passing just find faces. And this workflow might be preferred a lot of the times, and I'll be using it in my further examples, because a lot of the time computation of doing the actual analysis, doing the computation itself takes time, but then analyzing the results of that face detection, for instance, is going to be potentially sometimes try and error, experimenting with different plotting functions and operations, even experimenting with what color I want to specify for highlight video and so forth. For instance, here I can easily change and say I want these to be red instead of the default magenta. And so it's useful in most workflows to have analyzed the video itself first. That takes time, and then do most of the operations. So here we have fine faces on videos. Now, similar to that, we could do object detection on videos. Again, image bounding boxes of a video of a bunch of cars, a time series come back. Then the time series could be analyzed to count the objects, for instance. Here I have a little snippet of code that takes all the values of the time series, get the keys, and then flatten that, count that. So it says 25 cars across all the frames have been detected. This is not meaning we detected 25 unique cars, because the red car could be detected in frame 1, frame 2, frame 3. So we count all of those that got detected over the time. And notice that this is just 1 second of a video. Just like image bounding boxes for images can take that second argument that says only detect cars. I'm not interested in person, trees, trucks, whatever. We can zoom in on just the cars and then highlight just the cars on the video. Another set of functions that got updated that I would like to highlight are the segmentation functions. For instance, I have a video of a bunch of surfers on the water, and here I'm not using the functions directly on the video because some of these processing functions are not yet upgraded with video. We're looking at them one at a time to make sure it makes sense for all of them to operate on the video frame by frame. Sometimes it makes sense to, for instance, do remove background over time, not just frame by frame, for smoother background detection. So that's where some of these are not just operating directly. So anyways, here we are doing a video frame map. The function that's being applied to every frame is remove background with some specific methods specified. This usually inserts, not usually, this always inserts an alpha channel into the frame or into an image. We take the alpha channel, binarize that, save that back into another video object. Now we call that a video. Still, the head of that object is video. Now a function, a segmentation function like morphological components, can take that binary video, and I need to specify a threshold because there is no video file format that doesn't store stuff in the video without compression problems. So by default, morphological components takes all the non-zero pixels as foreground. I have to give it a threshold so that anything higher than that threshold is assumed to be foreground. Regardless of that detail, morphological components, like other components or segmentation functions, returns a time series, and that's a time series of some label matrices, which can be passed as well to highlight video. So here I have my components, my detected components separated, highlighted on that surfer video. One big functionality that got added 14.2 is video object tracking. So let me quickly go back. We talked about object detection in this previous slide and talked about the fact that, for instance, that counting is not taking into account that that red car is the same red car going forward. Or in that segmentation example, that was the last one, there is no notion of this surfer is that same surfer. So if the segmentation looks at all these blobs, it doesn't and it cannot keep coloring them as the same color because there is no notion of tracking at this point. It's just a frame by frame segmentation. Now, going back to my object tracking slide, video object tracking is a function that can take a video object in as an input, and that by default runs object detection and then tracks those bounding boxes. But as well as that, video object tracking can take objects such as points, bounding boxes, labeled bounding boxes or points, label matrices, or a timed version of any of those above. So let's look at a few examples. Oh, and as a result, video object tracking returns an object tracking data. The reason why we have introduced this new object is that there is a lot of valuable information that gets computed as these objects are tracked. And it's going to be really useful to just store them in an object so that we can, again, use those information later on for further analysis and drilling in. And if we don't store them right away, it's going to be expensive to recompute some of those properties. So with video object tracking, there's also object tracking data, which is an object that stores the tracking information. So here is the same example we had, the cars. I think here I'm using a longer version of the video. If I run image bounding boxes on video, and here I'm highlighting target device GPU, which is another addition in 14.2, can be used just for image object detection as well, but obviously is going to give us a bigger leverage when we are doing object detection on a video. So if I run image bounding boxes, find all the cars and every other things, here I have the boxes analyzed and detected. And if I run highlight video with those boxes, there is, again, no separation between automobile 1, car 2, car 3. These are all cars. We don't have a notion of how they are related to each other. Now, I had a bunch of boxes. I passed that into video object tracking. Again, as a reminder, I could have just passed video here to video object tracking. But because most of these operations on videos, and I'm not using long videos or very high resolution videos, as your videos get longer, high resolution, doing these in steps is going to save you time and avoid recomputing those capabilities. So I think this is a preferred or recommended workflow that I'm using here. So on those boxes, I run video object tracking. I get the object tracking data that I discussed that comes back. Type is bounding box, 125 frames. That's the length. That's the times. And then unique objects, we give just a snippet of what comes back. And I think I have it in the next section, so I don't show it. But a very quick mention that if I now pass that object tracking data to highlight video, again, highlight video nicely understands that, and not only understand it, it's actually coloring them based on the numbers, based on the unique labels that came back for each of these tracked objects. So things that we can do, simple additional analytics that could be run. For instance, I can take that object tracking data and ask for labels. And these are all the labels of tracked object in that video. So now instead of 25 cars that I got in the previous slide was only for 1 second of that video. But here we see that the largest number for the car that I have is just 11. And then a similar quick code to actually count by each type of the object that I got back. So we have 11 cars, 5 trucks, 7 people. And then another property that got stored as we were doing all of that tracking is, for instance, time interval. And then with time interval, I say car 1 was seen for almost half of the time in the video, but some of these other objects, I think I have some of the people that are only detected like this one, perhaps only for 1 frame, a person was detected. So potential filtering and other analytics can happen on those as well. One useful property that we have that can be extracted from object tracking data is sub-video. And for that, I'll have to pass the original video so that frames could be extracted. Remember, the way I constructed that object tracking data was just basically passing it boxes. So at that point, it didn't have any notion of the video where these boxes are coming from. So down in my analysis, I'm passing to the object tracking data my query being I would like to have the sub video for car number 2, and I pass it the video as well. And then this is basically a sub video of that very specific video that we had. For instance, I think in the documentation, one example we have is extracting facial emotions from people. And instead of doing such an operation frame by frame, it would be interesting to just track one person and say, overall in this video, this person seemed sad, seemed happy, and so forth. Or another thing that we could query is just the center position of the bounding boxes, or if you have points, just the position of those points, and then perform things like where this car appeared. This is just a highlight image, not a video. I'm taking the first frame. So that's the beginning, and this car ends up there in the video. With that, my next example is visualizing motion trajectories. Same video, I get all the positions, I delete missing and get the values and blah, blah, blah. This line plot of all of those points or positions that were extracted from object tracking data. This is basically the trajectory of all the cars in that video. And then here is a quick snippet to just track all of these cars as the video runs. Similarly to bounding box tracking, which has been the thing I showed so far, we also have point tracking. So here I have a video of a bunch of points moving around. These are some particles going on the random walk. Here the code is running a quick processing, binarizing the frames, because again, a lot of the times videos have compression artifacts. So we'll have to make sure we are zooming on white or pixels that have value of 1 or almost 1 in the image. And then we are doing a component measurements with centroid of all of the components that remain as a binary component in the image. And then we get the values of that. So if we run that on the video itself and then do object tracking on a bunch of particles that are XY coordinates, sometimes various methods that are fully documented in documentation could be useful. And there are plenty of examples for where and how these could make an effect if you want to drill into it. But as we have all the positions tracked, all the points tracked, and all the positions for these tracked objects or tracklets, this list line plot takes all of those positions and basically plots the trajectories into, this is a lower resolution one, into one plot. But with this quick code, we select every point whose trajectory is longer than 70 steps or 70 frames. And then we are basically plotting the same trajectory for those longer tracked particles. Segment tracking, another feature of these video object tracking function. Again, a little code snippet to do image processing on the video itself. Video map time series is running that code snippet on every frame of the video. And then as a result, what comes back, we colorize those. And if I put them into a video, this is basically the result of the segmentation, the result of the at this point untracked segmentation. So you can see a person who's walking here keeps changing colors because we don't have a notion of that person being the same person in the previous frame. Now, if I run video object tracking on the matrices that were computed before and then highlight that on the image, or in this case, I just create a video out of that, you can see that the person that is walking, each person, if the tracking algorithm is doing fine, is being colored by the same color. For instance, there the two people are overlapped. Perhaps our segmentation could be modified, but at least each person that's tracked is being colored with that same color. Okay, that concludes our object tracking. Let's move on to a few smaller but still significantly important features that got added into 14.2. One thing that was, I think, more of quality of life improvement is combining videos and still images. Two functions, video combine and video join, got updated to work with still images. And as an example here, I have a video combine example. I have an image from cellular automaton evaluation. It's very common to want to have to create a video where the background is just a constant image. There are plenty of them for music, for other things on YouTube, for instance. You cannot just upload an audio. You need to have a video. And that's still image, and then audio, you just get a video back with the duration of audio. And that's still image being just a constant video in the back. Similar thing is implemented in VideoJoin. Transcribing videos with the language option that got introduced. Previously, video transcribe was introduced, I think 14.0 or 14.1, but didn't take the language option. As our speech recognize got updated, now video transcribe can transcribe. For instance, here, the third audio track of this video is a German track. So we can say, we can give this hint of language is German to video transcribe function, and then we get a third track. This is the newly generated. That German one was the subtitle from the original video. This one that's already selected is the new one that's automatically generated. And then we can also say, get that audio track and assume either automatically compute or infer the language, or we can say this is explicitly German and translate that to English. So here, track 3 that's created and added is the transcription of the German audio track translated to English. And the last thing I want to show in the editing vein is that subtitle style has been added as an option to 14.2. Video transcribe and a few more functions take that create subtitles, can take subtitle style. For instance, here I'm specifying that the same evaluation that I had before. I'm just specifying a subtitle style that is a red on a light yellow background. And obviously the same text comes back here. The last thing that I want to talk about today is video object, notebook storage, and notebook sharing. Version 14.2 introduces an in-notebook storage of video object. However, this comes with a big exclamation mark. Store in notebook means that all of the video data still compressed in MP4 or any other compression, any codec that the original video has, gets stored in the video. If your video is a few megs large, probably fine. But if it ends up being 50 megs, 100 megs or higher, this will make your notebook very large and could give you hassle for saving, sharing, storing, and other problems. However, this could be handy for smaller videos. And with that store in the notebook is new in 14.2. Other options that have been available before were store in the cloud, either privately, just for you, under your account. And that's really useful when you're going from machine to machine and want to access your own private videos. Or you could store it in the cloud publicly, which is what I've done for most of the output videos in my notebook that you have downloaded. Let me drill into the details here a bit more. When we generate a video like that, most of the times, or all of the times, this is stored in user documents directory under Wolfram/video, and then we give the video an automatically generated file name. The input form of the video or information with resource path can reveal that location of the video. Now, 14.2 also adds to memory. In addition to that GUI, so here, if I look at that, I can also do copy resource path. And then when I paste it somewhere else, that's the same path that's stored in the video. So in addition to store in notebook that I can click, and then this is all of a sudden an in-memory, in-notebook video, I can also call programmatically to memory of a video. And then to memory brings the memory into the video. So at this point, you see, if I ask for copy resource path, that's going to be none. And we have removed the options of storing in the notebook or storing in the cloud. Maybe storing in the cloud could still be an option here. So with that, to memory, information of resource path similar to that GUI element gives none. And there are also programmatic ways to put things on the cloud, like that video transcode of the video object, and then I specifically say I want the asset location to be a public cloud object. And if I ask for information of resource path, I get that cloud object back with the right permissions.